Thank you, everyone. Cheri, Kevin, and Jason, thank you very much for joining us. So I think we all know that security, a lot of it is about imagination, right? You need imagination for security. And fortunate for us, we have a whole room of visionaries, so let's not really talk about that. What we also know, though, is that security, you need perspective, right? Like the perspective that Ben was sharing, looking at it from a different way. And so we are very fortunate to have the three of you with so much experience and perspective to be able to share some of that with us. So to start, why don't we perhaps start with you, Kevin, to share some of your perspective, and then we'll go around. Right.
Sure. So it gets really interesting when you start to integrate these components. Let's see if we move forward. Yeah. So I'd like to tell you a little bit about some things in terms of integration with medical technology. And so you saw from Ben a lot of the low level near the semiconductor, but don't forget meat space where the devices meet humans. So you'll find sensors in all sorts of medical devices, ranging from pacemakers and defibrillators to autonomous vehicles. Even in DC, can apparently lay claim to having one of the first underwater autonomous vehicles there on the upper right. And cube satellites in space, airbags, all these devices use sensors to make critical decisions, usually without a human in the loop. There have been security problems since the dawn of computing. It's just, they've always been there. And so none of these problems are new. The problem is that we're becoming more connected and we're depending more on these computers over time. So there have been a lot of interesting advances in this space and solutions. One of the more interesting solutions was involving physics, of course. Now, getting back to the meat space, you have places like the Food and Drug Administration, where I was previously the acting director for medical device security. And there we regulated a lot of medical devices. And a lot of them have sensors and AI technology, hundreds of thousands of medical devices. And so how do you protect that? There's plenty of what we call guidance. It's not a law, but it's a regulatory policy, and it explains to medical device manufacturers how to build in security to the early requirements and how to be able to show that a device is going to manage that risk. Not that you've got a checkbox of deploying or not deploying, but that you're managing risk and being honest about saying there is risk of cybersecurity problems. Just a quick introduction there before we pass it off to Cheri.
So I think, Kevin, that was great. And thank you very much for being the first cybersecurity director for the FDA. I mean, I have friends and family who use medical devices. And because of you, everybody's safer, so thank you. So Cheri, what kind of perspectives would you like to share?
Sure. Of course, I think as many speakers have already mentioned this morning, we have a once-generation spend on R&D, and we want to make sure that as we are spending not just through the CHIPS and Science Act, the Inflation Reduction Act, and the Bipartisan Infrastructure Law, as we're really moving to put a lot of resources behind research, modernization, upgrades for critical infrastructure, that also includes, that inevitably includes digitization and interconnection. So as we're bringing everything together, as we're converging all of these architectures, we really need to think about security by design, and especially where we're building new infrastructure. For example, in the Bipartisan Infrastructure Law, to meet the president's climate goals, we're spending $7.5 billion to build out the national network of EV charging infrastructure. That's fantastic, but we want to make sure from a supply chain perspective that we're building secure. And from a securing the grid perspective, things that are physically connecting into the grid that we depend on for so many things, we really need to make sure that that's secure. So there's an opportunity there as these major pieces of legislation, major investments that we're making for multiple years, we really have to double down on thinking about security by design, security by default. And so this is a major initiative for the administration, and you'll see it reflected in certainly the new National Cybersecurity Strategy that we released in March of this year, the National Strategy for Standards and Critical Emerging Technology that NIST is working on, and of course, implementing the CHIPS and Science Act. We need to make sure that all of that is infused with cybersecurity at the earliest possible stage. So From the perspective of my office, the Office of the National Cyber Director, the newest office in the White House, really formed to get after the growing cyber mission, coordinate across many technology sectors in this blended ecosystem, this converged architecture. We've released 2 strategies this year for the National Cybersecurity Strategy this year, and then previously in the work that I did prior to coming to the White House at the Department of Energy, we released a congressionally directed National Cyber-Informed Engineering Strategy, which I like to refer to as increasing the recommended daily allowance of cybersecurity for engineers, because engineers need it. There's not a lot of cybersecurity in the curricula for all kinds of engineers, electrical engineers, mechanical engineers. We really need to make sure that we're training engineers that are building and designing systems to think about security while they're at the earliest possible stage. And so we have a coordinated policy to do that, working with the national labs at the Department of Energy, but also working across a number of different partners in the academic space and all of our research entities within the federal space. So more to come there. We're looking, of course, at things like software bill of materials, hardware bill of materials. When we think about supply chain, really the best goal that we can have to manage risk is transparency. Everyone's risk is a very localized decision, but transparency of what's in the software that you're deploying, what's in the hardware to include the chips that you're deploying in critical systems, having better tools to provide that transparency is ultimately going to help us as we move forward in managing risk more effectively in the cybersecurity realm. So last, of course, one of the key focal points in the National Cyber Strategy that I'm working on is securing the clean energy transition. Clean energy is, of course, a priority for the administration, and the president has set out some very aggressive goals with having 50% of all new vehicle sales of being electric vehicles by 2030. That's a pretty aggressive goal, but I think we can meet it. But what does that mean from a cybersecurity standpoint? It means that the charging infrastructure that we're deploying now and for the next 5 years needs to be rapidly deployed, but also we need to think about the security of those components that are going into that new infrastructure from a continuing perspective. That doesn't just mean regular civilian type vehicles, but also, of course, there's a lot of DoD equities there as they're concerned about mission assurance for DoD logistics and movement. So as we're looking at clean energy transition, we're looking at decarbonizing the footprint of our federal agencies as well as nationally. How do we do that securely? So cybersecurity is a great enabler to make sure that our clean energy transition goals are fulfilled well. All right, let me pass that on.
All right, yeah. Thank you very much for the forward-looking leadership in terms of making everything secure for us. So Jason, what about you?
Yeah, so I'm going to take the perspective, of the hacker myself, a little bit about my background. I was part of the DEF CON Capture the Flag community, hosted CTF competitions, been involved with Hackasat, DARPA Cyber Grand Challenge, and various other efforts. From this perspective, the hackers look at things from a different perspective, I think, than the designers. Designers look at meeting the requirements and the specifications. We take a different approach. We look at what can we do with the system, right? What is available to us? What ways that we can break into the system? Maybe we don't have to enter through the normal mechanisms that you're familiar with, and take all these techniques and apply them. Also, one of the other things is a lot of this technology starts that the hackers apply. It starts in the early stages as kind of research and development, right? You see in academia, and then it becomes commoditized. Like today, we're seeing attacks from 2008 that are now being commoditized to bypass secure boot, read SD-RAM, things like that. And it's just becoming more and more common for us to employ, advanced technology and things like that as we look at these new systems. Lastly, it's becoming cheaper, right? These attacks that were theoretical in nature, that were very expensive, are now available online. You can purchase, like Chip Whisperer, SDR, things like that. So you can do, basically fault injection attacks, power clock glitching, look at side channel emissions. All of these things are very commoditized now, and they're being employed day to day and with hackers on nearly every system. So when we design these systems, we have to design them for the life cycle of the future, keeping in mind that today that our attacks are just theoretical or attacks that don't even exist yet, that may exist in the future. These systems have to be able to handle that.
All right. Well, thank you. I mean, it seems like design insecurity is a very, very common theme. But before we get into the questions, I mean, I think it's really funny that Jason mentioned this cold boot attack. Years ago, when the code boot attack first came out, I actually did a demonstration to a classroom of your everyday folk on the code boot attack. Right? So we had like business owners, you had teachers, you had farmers, we even had grandma, right? The quintessential grandma from a security literature was there. And so just picture, right? Just picture this, which is in front of this classroom, I had a big honking desktop. And like a magic trick that you would kind of see, I asked the audience to come up and enter some secret. It's going to be displayed on the screen. And as they were doing that, what I did was what you would see in the literature for the code boot attack. I took a can of air, turned it upside down, right? Turned and started to spray the memory chips. I turned the green and black memory chips an icy cold white, and then I pulled the plug to the horror of the audience, because they thought that secret that they put in there is completely lost forever. And then I waited again. 30 seconds later, plugged it back in, get the power, and magically we saw everyone, right? I was great and ecstatic that secret was still there. But do you know what the audience, what their reaction was? They said, right? They didn't care. And they didn't care because it wasn't really of their concern. So to start the questions, maybe what we should start with is with you, Cheri. What are your 2 top security concerns and why? Right? Help us all understand why we need to care about this.
So I think, my key concern, having worked most recently for the Department of Energy in the control system space, operational technology, is that converged architecture is here and it's coming fast. And we really, as we move to make more efficient, to digitize and interconnect absolutely everything, that's a great capability, but as we all know in technology, that capability always outpaces, always comes faster than the ability to consider privacy and security considerations. So the fact that technology is moving fast, that architecture is converging, and we don't really understand the security implications of that before it's fielded, it's out there, we're always ending up, kind of trying to clean it up after the fact. And so that's really, my key concern. And how do we run to get ahead as much as we can of the pace of technology?
Yeah, well, I think my top two would be one's classic, having security baked in. But when I think about security being baked in, I think of it as at the requirements phase, not the design phase and not the testing phase. I know somebody's out there who's doing it at the testing phase. We'll get you. But if you're trying to, pen testing has a role, but if the pen testing keeps you honest, but if you're finding the problems at that late stage and you haven't put the security into your early requirements, no wonder you have security problems. But the overarching one that I think sort of keeps me up is if we don't get the security well enough for the risk management, consumers are going to lose their confidence, and they're not going to be using, for instance, life-saving medical devices if they don't trust that they're going to behave as intended. And so we need to get the security story right so that we can innovate and that we can have the public believe in these devices because they're designed to work right.
For me, it's the 2 main ones is going to be legacy systems. There's just so many legacy systems in existence today, and they're going to be continuing operation for decades. I mean, we look at satellites, for example. We have satellites that are in space that have been there for 30 years, right? And they're still in operation. So there's theoretical attacks that exist today that when they were even designing them didn't even exist. We didn't even consider those like attack vectors. The other one is just the general apathy still to security, right? It's expensive, to do this. Not a lot of resources are available to implement it. So when people are going to consider designing systems, right, how much effort goes into designing in security from the beginning? And that especially is true in a lot of spaces, right, in the commercial space as well, right? We have systems that are in operation that maybe are life safety systems and other things where we need to build in more security at the beginning and not have that apathy. Bring in the cybersecurity research community into the design phase, design aspects of the system so that they can take into consideration the future life cycle of the system as well as the threats.
So I think this idea of building security in has been instilled in the security community for quite a long time, right? And so how do we share with the rest of the community? Let's say the business owners, the decision makers, right? Do you have any insights that you can share on things like maybe how do you measure security progress, or how do we make informed investment decisions? I mean, help us better kind of prepare and satisfy your dream of building security in. You know, who wants to start?
I'm happy to start. I think this is the challenge, that there is an endless amount of cybersecurity technology capability on the market. I see lots of companies spending to buy redundant solutions and really asking how much is enough. And so the measurement question is one that we've been grappling with for quite some time. But I think ultimately you have to understand what your goal is. And I think the goal, particularly from a supply chain perspective, has to be transparency. It has to be transparency and taking a risk managed posture. There is no magic cyber tool or capability that's going to eliminate your risk. But you need to have tools that are going to give you the right transparency to help you make managed risk decisions. So I think what I always advise when people say, well, how much money is enough to spend on cyber, really looking at the tools that will give you the transparency to help you make those informed decisions so that your C-suite understands the implications of what they're deciding.
Yeah, for me, it's a continuous process. There is no single process that can be applied that's going to be able to provide that measurement score or whatever somebody is looking for, because the threats are constantly evolving. So it's continuous evaluation of the security posture of the system from the life cycle, from development all the way to operation, to maintenance, to decommissioning of the systems, right? We have to maintain a constant presence during that process, and they have to be constant awareness for the security implications of the system. I don't think anybody's going to find a magic bullet or an algorithm or something that they could apply that's going to say your system is secure, right? I don't think there's an effective measure to do that. It's because security by its nature is addressing the unknown, right? There's constantly evolving field and new attacks coming out, and so you can't apply an algorithm in that capacity, right? And so you have to constantly do that measurement, that evaluation of the security system throughout its life cycle.
Yeah, so on the measurement, that's always hard, right? You can measure inputs, outputs, outcomes. You really want to get outcomes, but those are really hard to measure. I would say the best metric right now would be ounces.
Ounces.
And I say that in jest, of course, right? Because it's just really hard to measure security. And so the kind of things that you are going to measure probably are going to lead you down a path to the dark side, just because it's going to be the easiest things to measure. But I do like the discussion around risk management. So in academia, we often teach about controls. Deploy this, use this cryptographic technique. And it lends itself to a very yes/no checkboxy approach, and there's a role for that. But at the end of the day, it's really about managing the risk and accepting some risk and understanding what residual risk is there, what are some of the compensating controls, a timeline, and especially for finding ways to measure legacy devices that are not just insecure but insecurable. They might not even have a patching mechanism because they're so old. And I know some of you in the ICS community, with your Windows XP devices that you won't dare shut down. You'll say, "Oh, but it's on a secure network." Baloney. So metrics are hard, but I think risk management and just being honest that there will be risk is one approach.
So let's pull on that thread a little bit, right? Because it's very similar to what Jason Moore from AMD was saying. There's no binary. Right, kind of security, and it seems to be related to your hacker mindset. I mean, what do you think about that? Is that really true? I'm Jason. Sorry, the other Jason.
Yeah, absolutely. There is no binary answer to that that I can foresee and foresee in the future. I think everything that we've heard earlier from the previous panel discussion is basically just a summation of what we're saying right now, right? Is that we need to prepare for the future, right? Design in security, but also make systems that are life for the duration of their life cycle. They have the ability to be upgraded, the ability to be maintained, so they can get patches. And we also have to consider kind of that economic consequence of that, right? Like you have to be able to maintain these systems. You have legacy systems that maybe get inherited, companies go out of business. Who's responsible for the security and maintaining the security aspects of that system? I think that's a really difficult problem, that we can do it through policy, we can do it through, the cybersecurity research community, but it's, I think, going to be a combination of efforts.
Yeah. I mean, that seems very much related to some of, what you're talking, Cheri, about bill of materials and, the supply chain. I mean, is that all kind of incorporated in?
Yeah, I think, one of the, again, going back to the design phase, it's so critical with control systems. The challenge is you can't patch a lot of things in a timely way, the way that software-based systems are patchable. And a lot of the work that I did previously, I was in charge of cyber vulnerability testing at the Department of Energy. And I would say, 3/4 of the vulnerabilities that we would find in physical control systems were what I would not characterize as vulnerabilities, but as design weaknesses. As in, you would have to completely redesign the system to eliminate that vulnerability. Standoff mitigation might be the best that you could do. And so, just understanding that makes us want to put a lot more focus on security by design, of getting left of boom, of really increasing the amount of time that we're spending on left of boom activities, vulnerability identification, mitigation, threat sharing, versus, I think we're anecdotally 75% of current spending on cyber is right of boom, cleaning up afterwards. So how do we move that shifting left?
Yeah. Do you have any great ideas? Right. What should we do?
Well, this is why we're talking to the research community, because shifting left is inherently a research activity, and I think when it comes to deploying cybersecurity best, I do think that there are R&D opportunities there, especially if I'm talking to engineers. Engineers need tools to do their jobs, to design security in better. So what are the opportunities there for the research community to provide tools and pilots and implementation to show the way? It's really hard to get folks to adopt new ways of thinking, to shift their culture, to adopt more of a culture of security. Engineers are great with a culture of safety. The medical device community has a very strong culture of safety. How do we use some of that best practices from that culture to help ingrain a culture of security? So I think the research community can lead the way in helping practitioners see new ways to do their business, to provide examples, and to provide some tooling to help them.
Any comments on this interface between safety and security, Kevin?
Well, there's some interesting articles out there in the biomedical engineering community about safety versus security when it comes to medical devices. And it used to be sort of the two communities fighting, no, we're more important, no, we are. And then somebody said, no, you both are.
And don't forget privacy.
And don't forget privacy, too. Although that's Office of Civil Rights, and that's mostly handled in the courts and through fines rather than pre-market. What's interesting is a lot of the technology that can improve security also can improve safety and vice versa. Getting things at the requirements phase is something the safety community really cares about. There's a science and art of hazard analysis for safety. The equivalent for computer security is called threat modeling, and it has very different metrics. There's no, by the way, if you ever use probability as a metric for security, I authorize any to take you out, okay? Because you should never use probability. It's 1. I'll just tell you that. The answer is 1. But in the safety community, you do use probability. But so I think there's a lot that can be learned about how to combine these, where you can find certain sweet spots, which not only can make products more trustworthy and reliable and safer, but actually can reduce costs overall when you find these sweet spots, because you're able to have more of the confidence. You'll say, oh no, does that need to be on a secure network? Doesn't matter, because it's end-to-end. So I think there are a lot of interesting things from safety and security together.
Yeah. Any comments, Jason?
Yeah, one thing that I found was interesting is, sometimes security and safety, in these mission critical systems, right? Like if you're under attack, what do you do? And so a lot of times we talk about resiliency, right? Can the system continue to operate under attack? And it doesn't take a default posture, especially with a life critical device or a mission critical system, of shutting down, right? Like in your computer's case, yeah, you can do that, right? We can do forensic analysis. But on these systems that have life and safety concerns, it isn't as easy as saying shut the system off, right? Like that could be loss of life, that could be critical infrastructure components, things like that. And so we have to talk a lot about resiliency as well, as the system to be adaptable, under threat, for the system to react, for the people responsible to the system to respond and keep that system in operation.
I see. So imagine if we can keep these systems in operation and balance things out. Imagine that what Ben was talking about before, which is these kind of physical interface, right, and these very, very small, tiny microelectronic sensors, which are everywhere, is impacting the entire system. And especially because things are interconnected, right, it's just really impacting our everyday lives. So let's just imagine what happens if you had a magic wand. Well, we'll start with you, Jason. I mean, if you had a magic wand, and you can think, what would this kind of community that you can imagine look like? Right? What is it that you would imagine? What is that you can think of that can actually get us there?
Yeah, I think the community would look a lot like what we've seen in other industries, like with the car hacking village at DEF CON, right, where it was very closed in nature initially. Like the automotive industry was not open about their technology, open about their protocols. And then we kind of had this revelation moment, right, where somebody attacked one of the vehicles, right, and then the security research community started looking at this, and then the automotive industry kind of embraced, that aspect and brought that together. I would like to see that kind of stem across all industries, right? Bring that together in kind of an open community, doing that where you have folks that are, material scientists and you got cybersecurity experts, right? There's domain expertise and that cross-pollination needs to occur, right? Because a lot of what we're talking about is kind of like the physical domain components interacting with the sensors, interacting with the software, and there's a lot that stems there. So bringing in, the cybersecurity researchers into these fields early on and doing it without having to be kind of a knee-jerk reaction, I think is what's warranted. And that's what I would like to see the future look like. Instead of hackers having to constantly break into a system and say, yes, this is actually possible, now you care, right? Let's try to do that earlier than that stage.
Well, if I had a magic wand, especially in the context of medical devices and security of microelectronics, it would be to magically get rid of all the legacy hardware out there. Because, you go into a hospital, you'll find an MRI machine from 20 or 30 years ago, and what's the first thing to wear out? It's not the gear, it's Windows XP. Thank you, Seattle. Service Pack 1. Yeah. But in the reality, we're going to have a lot of legacy, and so my smaller magic wand would be is we just plan ahead to admit we're going to have legacy on day one. How can we cap the liability we're putting out there? So planning for those failures, making sure that things are patchable. There's a surprising number of IoT devices that don't have, they're not going to be able to survive a 0 day. How do you get things to move quickly without breaking things? Especially when you need to make sure that devices remain safe and effective, even if the network is under control of the adversary.
So my magic wand would be around awareness. Every day being, in the cybersecurity field for the past 20 years, I have somebody that comes up to me that says, well, I'm in the business of making washing machines. Cyber's not for me. Cyber is for all of you, every last one of you. I think that does limit some of the imagination that you talked about at the outset, but really understanding too that we live in complex ecosystems, that for the federal government, the way we tend to divide up the world is in terms of critical infrastructure sectors, the defense sector, the energy sector, the transportation sector. But in reality, we live in complex environments, increasingly complex and interconnected environments that implicate all of these sectors. So just in thinking about connected cars and electric vehicles, that implicates energy and transportation and critical manufacturing and communications, because it's all connected in the cloud. So, getting all of those folks to sit at the same table, have a community of interest around that ecosystem to understand each element, their distributed risk. These are highly, environments that have distributed risk, and cybersecurity, problems happen in the seams where everybody thinks, oh, somebody else is handling that problem, it's not me. But getting those communities together and talking and understanding where those risks handoffs are and being aware of what their actions are, the actions that they're taking and how they impact others in that ecosystem. I think that's where we're moving towards. But just the awareness is a key element of the starting point, and it's always distressing to find so many people that still don't really want to be aware of cybersecurity, but it's here.
Wow, this is actually fascinating, and it's great that we're here at this DARPA event ERI 2.0 because these sounds like really hard challenges. I mean, if I were to kind of summarize, if I may, Jason, you're really talking about this multidisciplinary nature of security, right? And being able to kind of combine everything together. And getting rid of legacy systems, that seems like a really hard challenge that maybe something, if you want, you're going to try to tackle as program manager, right? And Cheri, awareness. I think what you're saying is security in all these systems, because of the interconnectedness, is tightly coupled. And so this huge complex system, understanding that is in itself a nice challenge. And so those are great. So while we wrap up, I think, why don't, if I may ask each of you, if there's a simple call for action, what would you like the audience to know? Cheri, let's just start with you.
Okay. Certainly, again, I'm very focused on bringing more cybersecurity to engineers, looking at securing the clean energy transition, and would be happy to have everyone help join in our national cyber-informed engineering strategy implementation efforts. We have a community of practice around implementation details, standards, and workforce challenges. See me after class, and I'll be happy to tell you all about it and engage you. But then also, I am doing a workshop tomorrow. It's not in the book, but it is on the website, on electric vehicles, vehicle telematics security. So if that's your thing, please do come to my workshop tomorrow, and we're going to talk with folks from the National Labs, Department of Transportation, Department of Energy, and some folks I've got coming in from Detroit all about vehicle security and the intersection of power electronics and microelectronics. So
yeah, that's great.
Come on
Kevin?
down.
Yeah. I would say keep it tractable and actionable. And so the one thing I think every manufacturer should do is threat modeling. And the nice thing is there are shades of gray. So even a little bit of threat modeling can help at your requirements phase, or even if you have an existing product, sort of planning ahead for, here's what we're going to have to deal with later.
Yeah, mine would be engage the cybersecurity research community. Bring your stuff to DEF CON. I was just out at DEF CON, and one thing we saw was with the Hackasat competition is when we first started the competition, we were trying to get aerospace communities to bring their equities, and everybody said no, and now people are starting to say yes, right? And we see that shift, that dynamic. Engage the community, be active with the community. Let's have these open discussions and open forums so that we can talk about these difficult issues, and that's where diversity and innovation can stem from.
Yeah, great. Well, thank you, and thank you very much.
Thank you.
Thank you.